over sine squared x. Now, if we look at the keywords in the question, we've got show, we've got given that the derivative is this over here. So cos x over sine x is equal to -1 over sine squared x. So that means if I differentiate cos x divided by sine x, I get -1 over sine squared x. So if I integrate this function here, I will end up with cos x sine x. Now, there's a bit of a clue because they've given you this derivative. So we're expecting to come down to a function when we work this out to end up with -1 over sine squared x or something similar to this, so we can then use this to be able to give me the answer of cos x divided by sine x to help us work out this answer here. So our key formula that we're going to be using are the double angle formulae. Now you should know that cos 2x is equal to 2 cos squared x minus 1. So this is one of the double angle formulae, and it can be created from your formula sheet using the compound angle formulae for cos A plus B. So cos x or cos of 2x is equal to this expression here. But if you look in the question, we've got a 1 plus cos 2x. So we need to rearrange this to make it 1 plus cos 2x, which will be the same as 2 cos squared x. So we can then substitute this in. We will also need to know what sine of 2x is, because in the denominator we've got a sine of 2x. So we need to know that sine 2x is the same as 2 sine x cos x. Again, this could be generated from your formula sheet using the double angle formula for sine of A plus B. Press pause, have a go at using these double angle formulae to substitute into here, then put your limits in to work out this exact answer. Press play when you've had a go. Well done, guys. Hopefully you've managed to get an answer. So fantastic work. So the first thing we're going to do is we're going to substitute in, instead of 1 plus cos 2x, we're going to use this formula here of 2 cos squared x. So I've got 2 cos squared x, the square root of in the numerator. My denominator is still sine x, and then this sine 2x becomes 2 sine x cos x from the double angle formulas over here on the right hand side. Now in the numerator, I've got the square root of 2 times by the square root of cos squared x. Now the square root of cos squared is just cos x. And I'm going to take the factor of root 2 to the front of my integral. In the denominator, I've got a sine x times a sine x, which is a sine squared x. And again, I'm going to bring the constant to the front of the integral sign. So I've got root 2 over 2 at the front. The square root of cos squared is just cos x. Sine x times sine x gives me sine squared x, and the cos x just stays still. From here, I need to simplify. So you can see that I've got a cos x in the numerator and a cos x in the denominator. So these are going to cancel, and it's going to leave me with 1 over sine squared x. Now, if you look up here, what you've been given to start with, so the derivative of cos x divided by sine x is -1 over sine squared x. You can see it's looking pretty similar now to what you were already given. But what we've been given is a -1 over sine squared x. So to make this a -1 over sine squared x, I need to multiply the whole thing by -1. So I'm going to put a minus at the front, because this minus times the minus will give me the plus, which is what we've actually got. But we know the integral of this minus function gives me this. Once we've got to this stage here, we're going to actually use this rule here. So we know that if we integrate -1 over sine squared x, we end up with this expression here, cos x sine x. So we're going to replace this whole function with the limits of pi by 4 and pi by 6 to cos x over sine x between the limits of pi by 4 and pi by 6. So I have now got minus root 2 over 2 cos x over sine x between pi by 4 and pi by 6. Once we've got to this stage here, all I've got to do is substitute in the limits. So I always substitute in the top limit first, so pi by 4, then take away with pi by 6 in. So substituting pi by 4 in, I'm going to get cos x, which becomes cos of pi by 4, divided by sine x, becomes sine of pi by 4, minus cos x, which becomes cos of pi by 6, divided by sine of pi by 6 using the bottom limits. From here, we're just going to type the values into the calculator. You can do it in one stage if you like, or I've done it separately, so worked out each of these 4 values separately. So we should know that cos of pi by 4 and sine of pi by 4 are exactly the same, which are both root 2 over 2. So root 2 over 2 divided by root 2 over 2 is going to give me 1 because these two terms are exactly the same. Cos of pi by 6 is root 3 over 2 and sine of pi by 6 is a half. So if I simplify this, I'm left with 1 for the first two terms and then root 3 divided by 2 all divided by a half is just root 3. So I've got minus root 2 over 2, 1 minus root 3. From here, all I need to do is keep the half outside the front of the bracket because the expression we've got to show has got a half out the front. So I need to multiply both these terms in the bracket by minus root 2. So minus root 2 times by 1 gives me the minus root 2. And then minus root 2 times by the minus root 3. Two negatives gives me the positive. Root 2 times by root 3 is going to be root 6. Which is why I've got root 6 minus root 2. So that's all you need to show your answer. Make sure you give yourself a big tick if you got it correct. Well done. If you found this video useful, please share, like and subscribe so we can all get great at maths.